Hey guys, welcome to my second example of the rational root theorem. So earlier I showed you an example of how to use the rational root theorem, and I'm going to now show you another example of how to use the rational root theorem. Okay, so let's start by naming our polynomial x cubed plus 7x squared plus 15x plus 9. Okay, so I've highlighted what you need to know is the um, factors of the constant term. All right, the constant term is 9, so my step one is to identify the constant term, which is 9, and now I want to list the factors of 9. Okay, so factors of 9. So we know factors of 9 are plus or minus 1 times plus or minus 9, and then plus or minus 3 times itself. Okay, and now we want to know the factors of the leading coefficient, which is 1. Okay, and that's easy. That's plus or minus 1. Okay. Now I'm going to divide, right? Find out what are the possibilities, possible roots that I have here. And I can only do that by division, so that's P divided by Q. I have possibly 1 divided by 1, which is positive or negative 1. 3 divided by 3, which is positive or negative 3. And then 9 divided by 1 is positive or negative 9. So we have about 6 possibilities. Okay. All right, I have a positive 1, negative 1, positive 3, negative 3, a positive 9, and a negative 9. All right, and I'm going to try um, maybe some or all of them. We don't know yet, so let's double check. All right, with a calculator. So I'm going to start with a 1. Let me pull up my calculator. All right, and also notice that from the previous video, I've inputted the 1 here just to double check. Negative 1/3 and then negative 2 in the previous example. All right, and then you can see that they all equal 0. Okay, so let's go over it again. So we want to know for x is equal to 1. So there's 1 x squared, 1, 7, 15, and 9. So that's x squared, x cubed, and then positive 7x squared, and then positive 15 x, which is plus 9. Okay, and I'm going to show you that that's going to equal 32 because, they're all positives, right? So remember we want it to equal 0. So let's try the negative 1. So negative 1 cubed plus 7 times negative 1 squared plus 15 times negative 1 and then plus 9. Right? Okay, so I got a 0, and I can actually move forward from here, although I could test every single one of them. But let's move forward so we can show you how to do the rest. So negative 1 is one of our solutions. So if we know that negative 1 is one of your solutions, then we can synthetically divide, right? So we want to know, we know for sure that x equals negative 1. So that leads us, by the factor theorem, that x plus 1 is a factor. Okay, and it's because that's a factor, we can divide and get no remainder. So we can divide x cubed plus 7x squared plus 15x plus 9, I believe, right? And we can divide that by x plus 1 and find out what our quotient is. Okay, so I'm going to use synthetic division and plug in a negative 1 here, right? My coefficients are 1, 7, 15, and 9. Okay, I'm going to skip a line, and I'm going to draw a line, okay? So bring down my 1, and I'll get 1. 1 times negative 1 is negative 1. 7 minus 1 is 6. Negative 1 times 6 is negative 6. 15 minus 6 is 9, and then negative 1 times 9 is negative 9, and that gives me a 0. Okay, and just like as I calculated, it would give me a 0 as my remainder. So then more importantly, what you want to know is what's your quotient. So your quotient here is x squared plus 6x plus 9. All right, so now we know that our original factor that we had gotten here is x plus 1. And from dividing, I got the quotient x squared plus 6x plus 9, okay? Which you know this is, again, factorable, right? Because I could find factors of 9 that when I add them is equal to 6. So factors of 9 and when I add them is equal to 6 is 3 and 3. So this is equivalent to x plus 3 times x plus 3, which is x plus 3 squared, right? So this is a fully factored form, x plus 1 times x plus 3 all squared, right? Because you can combine these two together since they're the same. So now we can actually solve it once it's factored, okay? So now that's equal to 0. So x plus 1, if that's equal to 0, we found out earlier that x is equal to -1. And if x plus 3 all squared is equal to 0, then x should equal -3. All right, so you have two solutions there, -1 and -3. All right, thank you for watching this video.